All right, class.
Yes.
You have officially practiced and reviewed and done slides, and you already actually quizzed over electricity. So I'm curious for that last question on your quiz. It said, how does electric force affect objects? And I had some of my scientists that were really smart, and you started thinking about words like attract or repel, and you knew that electric forces did those things, but there's some kind of charges involved with that. Who can help us recap on that? What charges made things together attracting? How can you use scientific vocabulary to answer that? Addison?
Negative and
Static.
if you have negative and negative charges, they'll push each other away.
Ooh, and if they're pushing away, we call that repelling. Good. So if you've got two negatives, which means they're the same, they're going to repel. Very good. What if I have two positives? Real? They're going to repel also because they're the same. If I have two positives, they will repel. What if I have opposites, like a negative and a positive? Keegan.
They're going to be
They're going to connect. What's my word, my scientific word for that, Rylan? Rylan, you sound like the rest of the class. What is it? Attract. If the opposite electrical charges will attract, the same electrical charges will repel. So we've wrapped that up. I'm really excited.
repel.
I'm really excited because our next lesson is all about magnetism. And our big question that we're thinking about is, how can you use a magnet? So I'm ready to preview a little bit. You ready to join me?
Yes.
Check it out.
Get out. I watched it. My
Check
name's
it out.
Antonia.
So just a little quick recap here. I shifted, we're done with electricity, so I shifted my lesson to lesson 2, magnets. And I need a flip-flop, but I forgot I would open a new tab. So let me switch this really quickly here.
Are you going to call groups?
If you are in restroom group 5, you get to go first today. So you very quickly, quietly get your hands washed for lunch, please.
Do we wash?
So friends, we're officially on lesson 2, magnets. What are we going to be learning about? So here's our first page Keeley activity. There's a picture of a magnet here, and there's a north pole on this magnet and a south pole on this magnet. And if you've got a big magnet that's being used for experiments, you're going to notice that they're labeled that way. They usually just have an N and an S. And so those are just laying on a table next to a paper clip. Now here is their question for this activity. It says magnets are used to attract or bring together objects. They move toward the magnet. Magnets are also used to repel objects. They move away from the object or the magnet. What happens when a bar magnet, which is these ones with the north and the south pole, is placed near a steel or metal paperclip? Circle the best answer. So you are going to open your workbooks to page 70. What page do you need?
70.
I'll give you 10 seconds to have your workbook out and open to page 70. 10,
Workbook or science
9,
book?
science workbook. 8,
Wait, what page?
7, 70. 6, 5, 4, 3, 2, and if you're not there yet, you're quickly getting to 70, and I'm going to read. A, both ends of the magnet will attract to the paperclip. B, one end of the magnet will attract the paperclip, and the other end will repel the paperclip. Or C, both ends will repel the paperclip. Circle which one do you think is the best answer. Do you think A, the north and south poles will attract it? B, one end will attract and the other will repel? Or C, both will repel? Landon, we're in our science workbook, page 70.
What's the difference from
We're gonna have to learn about that, huh? Macy, we're in our science workbook, page 70. Do you think both will attract, both will repel, or one will attract and one will repel? Bless you. Jade, as you come in, we're in our science workbook, page 70. Something really smart that I noticed Jade did is she grabbed her coat when she went to wash hands for recess. If you forgot it, just grab it when we walk by. But group 4, you may go wash hands for lunch and recess and bring your coats back in when you're ready. Okay? How many of you, by show of hands, think that both of the ends will attract it? It doesn't matter which side of the magnet you face the paper clip, both of them are going to bring the magnet to it. Nobody. That works too. How many of you think, oh, okay, Maddie does. How many of you think one side's going to attract it and the other side's going to repel it? Okay, some of you are choosing B. How many of you think both sides of the magnet are going to repel or push that paper clip away? Rylan? Okay, cool. Let's go ahead and learn a little bit more about that, because I heard some questions and some of you were wondering, what do the N and the S even mean? What's the difference between those two sides? So we're going to find out a little bit more about that. I want you to check out this picture. This is a pencil that's just kind of stuck into a block of clay. And they put magnet rings on the pencil and they kind of levitate. They just kind of hover there instead of falling and stacking and sticking to each other. They're balanced in between each other. I'm curious what questions you have. So as you look at this is a silent in your brain thing, but I want you thinking, and it's at the top of page 71. What are some things that you wonder about this picture? Jot down your questions. You need at least one, bonus points if you have 2, things that you're wondering about this picture, questions that you want to know more about. Top of page 71 says, look at the photo of the magnet levitating on the pencil. What questions do you have? And as you're jotting your questions, I would like to read to you about Antonio. He's a robotics engineer, but he's talking about a career of a magician. So some of you might be intrigued by this. Antonio says, I would like to create a new magic trick for my show. My audiences love tricks that make objects float or levitate. Some of my tricks involve the use of magnets. Magnets can push or pull each other. And even though the tricks look magical, they're really just science demonstrations. One trick that I do for birthday celebrations, birthday parties, involves making an object levitate on a pencil. Children are amazed by this trick, and I always get loud applause. So we were writing questions about this picture. On the top of workbook page 71, who has a question that they would like answered? And I'll jot them down in my workbook then. River, what's your question? Why do they hover? I love that you found a synonym for levitate or float. Why do the magnets hover? Anybody have a different question? And really be listening so you don't repeat them, because we don't want to have repeat questions on my list, right? Addison.
How does it float?
Oh, so I'll add how. How or why do they hover or float? Landon?
How does it levitate?
Oop, that sounds the same, right? How does it float? How does it levitate? I love that you guys are thinking of those, but really listen so we don't repeat. Does anybody have a different question? Something else you're wondering about this picture? Riley?
You have to have the exact shape of magnets in the picture.
Oh, so do only this type of magnet work for this trick? That's a good question. Emerson?
Maybe they are both positive charges.
Oh, do they both have positive charges?
Or are they?
Skylar?
Do you have to do it with clay, and can you do it with a different object?
Will other objects work? Rylan?
So they have the same belt of magnets. They have the same.
Good. Do they have the same magnets? I like your questions. I do want to expand on their magician bit because I want you thinking, and you won't have to answer these questions by writing them. We'll talk about them instead. But this expands on what Antonio told us about a magician in your workbook. And they say, magicians use magnets to entertain us. Because magnets can push or pull objects, magicians use them in their tricks. They might look like magic, but they're really a science demonstration. From this, you guys can actually infer something as readers. So I'm going to ask you a question and see if you inferred it correctly. Everybody have their thinking caps on? Is magic real? Can we really make things move with magic? Or is it science? And I want to hear you talk to your neighbors about this. Is it really something magical or is it science?
Science.
Teach.
Science.
Whoa, try that again. Teach.
Okay.
All right, talk to them and say why. Prove your answer. Prove your answer.
Science is
So,
magical. Science is magical.
I think magic is not magic because magic is not real.
Oh my God. I am going to have you record your thoughts for this on your slides. What are you thinking? Is magic real? And if it is, how do you know? If it's not, how do you know? What are they really doing?